Cool. Thank you for the introduction, Joaquin. I really appreciate it. I'm actually super excited to be here talking to an OWASP chapter, especially because I was realizing, as Joaquin was telling about all the cool things that OWASP does, that a lot of my knowledge about web security came from reading OWASP guides and OWASP top 10. Like, I remember being a master's student, and my advisor was like, okay, we need to include this vulnerability, and this vulnerability. And I'm like, I don't really know what those are. So you go look them up, and that leads you to OWASP guides that tell you more about them. So I'm actually I'm really excited to be here today to talk to everyone. So what I'm going to really focus on this talk is black box web vulnerability scanners. So how many people know about these tools, use these tools? Some of you? Okay, cool. And really what I want to do, and kind of what I want to start, is a little bit of a conversation. So it's very easy for us in academia to be in our ivory towers and do security stuff without ever talking to practical security people about what actual challenges they have, how they use these tools that we try to study and try to improve. So that's really kind of, if I could take away one thing from this, that would be what I'd love to hear from you, is feedback about how you use these things. Where do you see these tools going? Can these tools help you be more effective in your job? So a little bit about my background. So this is UC Santa Barbara, for those that don't know. Yes, it is incredibly beautiful. It's on the water by 4 sides. This is actually the campus, and this is probably about where, I think that's where I spent most of my time in the engineering buildings. I'm a triple gaucho. So I did a 5-year bachelor master. That's the mascot of Santa Barbara. It's an Argentinian cowboy. There, you learned one thing today. Awesome. So I did kind of like the 4+1 at ASU. I did a bachelor master's at Santa Barbara. During my master's, I got into research. So actually, some of the work I'm going to present is from my master's work there. I did that, and then I was like, man, I'm so done with academia. I'm going to go work in the industry. I'm going to make a ton of money. It's going to be awesome. And then I went to Microsoft, where I worked full-time as a software developer up in Redmond. And I actually loved that. I really liked software development, but I really missed security. And I found out that I really like doing research, like doing cool, new stuff that nobody's ever done before. I like to tell students, at Microsoft, I was doing something new, right? It was new to me. I'd never built this kind of system before, but I was kind of building the same thing. But in academia, you get to kind of tackle these new, interesting problems that maybe nobody's ever solved or thought about before. So I went back to Santa Barbara, did a PhD, and while I was there, Team Shellfish was my hacking team there, so we competed in a bunch of hacking competitions. I did compete in DEF CON. I don't know how well we actually did. I don't really want to look at the results, but we never did great. They keep changing things on us. Like, one year we showed up and it was all IPv6 and all of our protection stuff was all IPv4. And one year it was ARM, and I was like, I'm too old to learn another architecture. But that's the way it goes. So then I was super stoked. I got a position here at ASU in Tempe. I've been here in August, it'll be my 2nd year here. So I'm still relatively new to the area, still trying to deal with the heat thing that's going on out there. But I'm surviving, and I'm starting a hacking group at ASU called the Phone Devils. So some of my teammates are in the room watching. So we competed in DEF CON quals. How did we do?
I think we got 67th place.
Hey, 67.
Out of 256.
Out of 256, so that's not too bad. But we're moving on up. We're moving on up. This poor guy had a whole whiteboard in one of the other rooms filled with crazy equations that those horrible DEF CON people created for us. But,
just think about it.
Please, go ahead. So that's kind of brings you to where I am here. I don't really have, but I have a little bit, I could say the tiniest bit of industry experience. I've done some professional pen testing things, I think 3 of them with my advisor. But I don't have your experience in what you see every day out there. So obviously, I guess it kind of seems silly to be able to have to talk about some of these things at OWASP, but I like to kind of cover the basics, that way we're all on the same page. So web applications are really important, right? think we can all agree on that. Otherwise, you probably wouldn't be here unless you're just here for the free food, which is cool food, right? We talk to people. We put our money online. I know me personally, I'm like appalled anytime I have to go physically into a bank. Like, what do you mean I have to go into the bank? Like, I'm not going to deposit a check on my phone, right? I don't barely even go in there. Right? There's all these services now where we can put our healthcare records online. We can file our taxes. And remember the problems that the IRS was having with people claiming other people's returns? Yeah, right? All of these are web applications, right? Accessible over the web. And they're such an important part of our lives that when things happen and they go wrong, right, things can go really wrong. So I like this example is when UCLA had 800,000 of their information hacked. I was actually one of these 800,000 people. I did not go to UCLA, but because I applied there, my data was part of this data that was in this breach. One of my favorite hacker stories, especially one that I like to tell in class, about Albert Gonzalez and their crew, where they stole credit cards from TJ Maxx and other companies, and he got, I think, 20 years in prison for causing about $200 million worth of damages. And they were exploiting. It's actually great. Have you seen the, I think it's the American Greed episode on his crew? But that is beautiful, like, SQL Injection attack goes across the street. Like, that's the crazy technical vulnerability they use to get all these credit cards. The Target breach, 110 million credit cards stolen. I was also part of that. That's a very personal, right? I swear, I don't like them. Very good. It's like buying things. The OPM breach last summer, right? You were a part of that, anybody else? I actually don't think I was, but who knows, maybe. But actually, from talking with people, right, even if you weren't, if somebody you know was part of that breach, right, because it contained all the sensitive, top secret clearance level stuff, your information was also contained in that breach, and so your information is out there. So I talked to some FBI agents about this, and they said it's very worrying that somebody has all this data of all these people who have very important information. Yeah, so the OPM, 22.1 million people, it's crazy. One that I really, well, I guess I should ask if anybody's from any of these companies first, but it happens to everyone. It's not you, it's everyone, right? I like the JPMorgan Chase hack, specifically because they say that the hackers came in through the front door, right? Well, what do they mean by the front door? Well, they mean they exploited an overlooked flaw in one of the bank's websites, right? And so that, I think, really underscores the importance of web applications, right? To me, honestly, if a company doesn't have a web application, it may as well, I mean, a website or some web presence, it may as well not exist, right? Like, how many of you decide where to eat based on, like, Yelp reviews and then checking a menu? If you can't see a menu on your phone before you go there, it's like, unless somebody tells me it's the best tacos they've ever had, I'm not going there, right? And so, why web applications? Why, right? Why, it kind of helps to think about the attacker's motivation, right? Why are they after web applications? Well, some of you have looked at web applications and they know that sometimes they're a jumble, right? They're thrown together. There's tons of different technologies that are all coming together to build this one, just to serve this HTML page, right? So much stuff is happening on the back end. I know I've personally been guilty of this as a PHP developer back in my day, not knowing what the heck I was doing, but gluing and taping things together until it worked and pushing it out there. And now it's on the web. And not only is it on the web, but it's open 24 hours, right? And that's the beauty of the web, is anybody can access it at any time from anywhere. Unfortunately, this means the exact same thing for attackers, right? They can attack our websites, our web applications, anytime from anywhere. And we increasingly have sensitive data in these web applications, right? So, and this is what I like to do with the technology. So this is actually slides maybe familiar to some people. I know there's at least one person who's taken one of my grad classes. This is all of the kind of like technologies that I go over in my grad web security class. You think about all these things that you have to learn about and understand really deeply to be able to either create a secure application or to be able to find vulnerabilities in these applications. And really it's kind of this is what I see, it's like this big spaghetti thing of all these different technologies kind of all mixed together. And it's really easy for vulnerabilities to happen, and it's really easy for developers of these web applications to make mistakes. Okay, just to kind of refresh. So what is a web application? What do I mean by this? So we have our browser, right? We have some kind of server running some server-side code, maybe it's PHP. We have some back-end database, maybe it's MySQL. The client makes an HTTP request to the web server, where the web server processes it using its server-side code, maybe makes some queries to the database to fetch some data, get some data back. Finally, the goal of the web server is to return an HTML page with CSS and JavaScript using an HTTP response, which disappeared, to the browser, right? Where the browser then takes those raw bytes that it got, interprets it, and displays it to the user in a nice, beautiful, graphical user interface, which then the user can interact with, and this whole cycle kind of repeats, right? So where can vulnerabilities occur? So I just want to cover very basically SQL injection and cross-site scripting so that we can know when we talk about these tools, the goal of the tools is to automatically find these vulnerabilities. Well, how do they do that, and what do they look for? So SQL injection comes in here into the picture, the interaction between the web server and the backend database, right? And so the idea is there's some kind of code on the backend server that creates and constructs a SQL query, right? And it does so by concatenating strings together. So here we're creating a SQL query in PHP, right? So we want to run the SQL query, select star from users where the name, so select everything from the users table where the column name is equal to some value supplied by the user, right? And this is very natural for developers. This is how they want. They're creating some queries so they concatenate some strings together. And so if the name is something random, right? The server-side code processes, and it just concatenates these strings together, right? PHP just puts these strings together, sends this off to the backend database, where the backend database, remember, just gets these sequence of bytes. And then it has to parse it to understand, okay, what was the structure of this query, and how can I interpret that? So then they interpret this query, and they say, okay, select everywhere from the users where the name is WackoPicko. Perfect, I can do that. And so we can do other things, right? What if the attacker can control this name value variable, let's say it comes from something from the user, it comes from part of the URL, part of the query parameters of the URL, or it comes from post requests in the forms, right? If an attacker can control this and now submit arbitrary data, well, if they input something like this, a tick, semicolon, drop table users, now the server-side code does the exact same thing in the previous situation, right? It just concatenates strings, that's all it's doing. So it concatenates these strings together, it takes that result, and it sends it to the SQL server, where now the SQL server has to parse it and say, okay, what query did the developer actually intend to get executed? And in this case, the attackers tricked the SQL server to execute two queries, right? One query to select everything from the users where the name is A, and the other one is to drop the user table, right? Now we've just lost our whole user table here from one query, right? And this is not the only thing you can do with the SQL injection vulnerability. You can also extract all of the tables, all of the information from your database. You can also insert and possibly change data. So you get basically, it's really, really bad, right? They can steal your database, they can basically delete your database, and they can arbitrarily change your database. Right? Just with one little mistake, anybody on earth can do this. Any questions so far? Feel free to raise your hands and stuff. Pretty nice, most of the time. Okay, so that's SQL injection. The other type of vulnerability that's really popular, I don't know off the top of my head where it falls in the OWASP list. Hopefully somebody can maybe tell us. Is it comes in between here with the server-side code generation of the HTML page. And that's one of the most famous vulnerabilities is cross-site scripting, right? So the idea here, and again, these are actually, even though we think of them as kind of two different vulnerability classes, they really stem from the same problem, which is that the web application is generating some language, right? In this case, in one case a SQL query, one case an HTML page, by concatenating strings that another parser has to interpret here. And so let's say we have this HTML, is this PHP-ish code? I think it's PHP code, right? Remember, I have some stuff with ASP.NET. It's a little weird. Okay, so here we're taking the name variable, and what this means is everything that's not in the angle bracket and the question mark is going to be constant. Right? So everything that's not inside those purple tags is going to be constant. At runtime, the server-side code will replace by using this, whatever's inside that name variable right there in the output. Right? So it's essentially, again, concatenating strings. Right? It's concatenating everything before the purple tags, substituting, concatenating that with whatever the name variable is, and concatenating that with everything afterwards. So if we, some other random name, right? If the name happens to be Adam, the server-side code substitute that into that name variable. Then the important thing is, right, that server-side code is just sending an HTTP request back to the client. The client then has to take that, parse it, and interpret it as HTML. Right? It has to make sense of what it got from the server. So here, it parses it, and it interprets all those tags as HTML tags. Right? And then the screen's going to show hello Adam. Now, if I instead had the name be some fragment of HTML or something, right? Once again, the same thing happens. The server-side code simply inserts whatever's in that variable in the output, sends it to the browser. Now the browser code parses it, and then when it sees these script tags, it says, oh, this is inline JavaScript code. I should execute this. This is what the developer of this web application wanted to happen. And we'll see a JavaScript alert. So, and this is really the fundamental problem of cross-site scripting, is that an adversary can trick you to execute JavaScript. The whole thing is saying origin policy, but we won't go into that. And so what I really like about cross-site scripting vulnerabilities is once the adversary or the attacker gets you to execute arbitrary JavaScript, they can do really cool things. So they can make requests to the server on your behalf. So if this is Facebook and they trick you to, they use a cross-site scripting vulnerability in Facebook to get you to execute some JavaScript code, they can have that JavaScript code post on your wall, post on your friend's wall, friend random people. If it's a bank account, they could try to initiate a transfer from your funds to somebody else's funds. They can basically impersonate you and do everything that you could do on that web application. This is why this is a very serious vulnerability. They can get all those requests. And the very cool thing is that the server doesn't know that you didn't do that. Right? It just sees this request come in and it goes, okay, yeah, I'll post that message or I'll transfer those money. Right? Okay, so now we get to the main events. Right? The black box web vulnerability scanners. So these are usually commercial tools, also open source tools. Anybody familiar with any of these, and which ones are you familiar with? So I can do a brief poll. Update my knowledge. Yeah.
Fortify, Portswigger, Venti Objectives.
Yes.
Portswigger, definitely Portswigger.
3 of them. Anybody familiar with any other ones?
Acunetix.
What was it?
45.
Fortify. Thanks. Acunetix. Anybody use one that's not on this list? I need to update my logos.
WebInspect.
What was it?
WebInspect.
Ooh, what was it? Rabbit?
WebInspect.
Ah, WebInspect. Zap. Zap. Oh, See, I told you I was out of practice. In my pocket. All right. That'll be a cool start. Was it?
NetSparker.
NetSparker, yes.
Very good.
Fair code. Cool. Yeah, all different types of tools, right? And so if we kind of break apart what these are, right? They're black box, which as we'll see means they have no knowledge of the source code of the application, right? They exist completely outside of the application. Web applications, so they target web applications, right? And vulnerability scanners, they're trying to find unknown vulnerabilities in these applications. They're trying to find SQL injection and cross-site scripting vulnerabilities in a web application with no user interaction, right? That's kind of the holy grail. So these are considered, I kind of think of them as like point and shoot tools. It's like you just point them to a website and they try to do what they can to find some vulnerabilities, and then they bring you back a report that says, hey, I found these things, here's what they are. So why is that? So, and they definitely have benefits, right? one of the beauties of these tools is because they're black box, right? They don't care what server-side code your web application is written in. They can try to hack into and try to find vulnerabilities in a Haskell application just as well as a Ruby application, as PHP, Python, whatever crazy language you want to write your web application in, right? Because they access it just like a user, right? So that's nice. One of the other things is that, well, actually we'll get into that later, but that's one of, I think, the main benefits. So how do these tools work? Well, they treat the web application completely as a black box. They don't know if it has a database, they don't care. All they do is make HTTP requests, get HTTP responses back with the HTML, CSS, and JavaScript, and they continue doing this. So they go throughout the web application, making requests, getting responses, going to another part of the page, another part of the web application, making new requests, getting new responses, making new requests, and getting new responses. And the goal is to try to infer the existence of a bug in the web application. And say, yes, give you a report that says, I think there's a SQL injection vulnerability because I gave it this request. It sent me this response. That means there should be a SQL injection vulnerability. And this is great, right? It's an automated tool. You can just do this. So how do they actually work, right? So they have three main components. They have the crawling component, so they need to be able to try to discover and interact with as much of the application as possible, right? That's their whole goal. They want to find vulnerabilities. They want to crawl and find as much of the application as possible. They have an attack module that actually says, okay, try this input. It's likely to trigger some kind of fault. So for SQL injection, usually what they do is they'll try input with ticks. Well, there's all kinds of stuff, but one of the ways is they'll try to put ticks in it to try to cause a SQL error to occur. And they know if they've done this, and they usually will look for keywords like error or SQL error or something and say that, hey, this vulnerability actually occurred. For cross-site scripting, they use the huge list, which I believe now is maintained by OWASP, and used to be, was it Rsnake? The cross-site scripting cheat sheet. There's a bunch of input that they try, and the other important part is the analysis module. So this gets back the response and tries to answer the question, okay, was it vulnerable, right? Did that website actually have a vulnerability based on that attack? And they kind of try to feed into each other because you may discover more pages as you're attacking, and so then you want to crawl those pages. You may want to attack while you crawl. That's kind of an interesting design choice of how the tools do that. So we tried to ask the question, are these tools any good, right? You know, it's actually something that's kind of difficult to say, right? Because if you run the tool on your website, it tells you some vulnerabilities, you find some. I don't know, what do you think? Like, yeah, was it worth it? Was it worth 10 grand or whatever these tools cost? I don't actually know any numbers. If somebody wants to secretly give me some data of what people are paying for these, that would be awesome too. Right, so, you know, but that's, the key problem with black box tools is, okay, it told you there were 2 vulnerabilities. Does that mean you don't have any more vulnerabilities? You're all done, you can go home? Right? How many vulnerabilities did it miss, and why did it miss those vulnerabilities, right? So that's what we tried to do, and we created an intentionally vulnerable web application called WackoPicko. And it's a pretty fully featured, I'd say, web application. It's got, you know, user credentials, you can log in, you can register as a user, you can log in, you can upload photos, you can like purchase a photo, you can comment on photos. I don't know, all kinds of, you know, good. You can see it was done in like the Web 2.0 time with all the rounded corners maybe, some of you web developers. Also I'm not, you know my last name is French, I don't actually speak French. This will have a link to it in a bit, but there's a guy who created a wiki about all the vulnerabilities here, so I like stole his screenshot and I noticed, I don't know what this says, so I should, before anybody asks me in case it's offensive. Okay, so we put 16 intentional vulnerabilities in here. Some normal ones, cross-site scripting, SQL injection, all the way to command injection, all types of vulnerabilities. We had a logical flaw in the application where you could submit a coupon multiple times to drive the price down to 0. Just to try to get a handle on and maybe somebody who's a fast counter can see that this is probably not 16. Is that correct? You gotta get there before the audience. That's always the trick about presenting, especially in class. We also had multiple of the same vulnerabilities. We had stored and reflected cross-site scripting, obviously. We also had some vulnerabilities that were behind a login, so we could see if they would log into the website, if we gave them a user account. We had some vulnerabilities that were only accessible after a multi-stage process. So to post a comment, you had to fill out the text, click the submit button, which would take you to another page that said, hey, here's what your comment's going to be. Would you actually like to post this? And then you say yes. So it's kind of a two-step workflow there to try to test the scanners in that sense. So we did this, and then we ran, I think it's 11. What did I say? Is that right? Yeah, I think so. Okay, we ran 11 of the vulnerability scanners against our web application. We actually ran them in 3 different configuration modes, but I won't go into the details. I'm kind of giving the abbreviated things. I can go into other cool stuff. And so basically the takeaway is no tool found over 40% of the vulnerabilities, and combined, even across all of the tools, they didn't find more than, I think, 50% of the vulnerabilities. So there's a huge, and you can see there's a huge kind of variance in these tools, right? Like some of the tools, like on some vulnerabilities, like Burp was actually pretty good, but some things like Red Scan, which may not exist anymore, MileScan, NTO Spider, yeah. So there's a huge range in what they found and didn't find. So it kind of is interesting to look at, well, what did they miss, right? Well, some of them they missed. There was a weak session ID in an admin page, so they missed that one. There was a weak password, where one of the user accounts of the password was admin, so they didn't get that. Parameter manipulation, this is an interesting one, where you could modify a parameter to access pages that you shouldn't be able to access, right? So kind of like a horizontal privilege escalation. Forceful browsing, you could forcefully browse to certain pages that were supposed to be only protected after you purchase them. And the logic flaw. There's also a stored SQL injection that they didn't check. Oh, because this was a second order SQL injection. So if you created a user account and then later changed your password, it would trigger a second order SQL injection. Yeah, I don't know why they didn't. I think when uploading a picture, there was a directory traversal vulnerability, so they didn't find any of those. And the stored cross-site scripting behind the login, this was very strange, and they did not actually detect this. And one more other interesting things. So missed vulnerabilities, right? These were like false negatives, and it's actually, this is one of the only ways you can actually measure, okay, precisely how many vulnerabilities did they miss, right? Because I created this thing, I know how many vulnerabilities there are in there, and so therefore I can tell how many they actually miss. False positives, right? So false positives are when the tool reports a vulnerability, it says, hey, I found a SQL injection here, and you go and look, and you verify, no, there is no SQL injection. Is this like the bane of everybody who's ever used these tools' existence? Or false positive things in general of any automated system?
Click checking.
Huh?
Click checking. That's a joke.
Click checking. Yeah, so actually the false positive range between the tools from anywhere, some tools had 0, some tools had 200 false positives, which is, yeah, insane trying to think about that. The average was about 25. One of the key things I always try to look at is why. Yeah?
Just curious, did you find any correlation between the number of false positives and the coverage that they got? Like the more coverage they had, the more false positives they had?
I do not know. I don't think it was exactly like that. And I think the 200 plus is going to throw things out of whack because I know that tool found a lot of vulnerability. Was towards the top in terms of finding vulnerabilities, but I don't think it. So I think that would probably skew things. But yeah, that's a very good. That would be an interesting thing to look at. One thing was one of the tools reported a server path disclosure on every URL that started with a slash. It's like, oh, /user/home, that's a local path, server path disclosure. And we're like, no, that's a URL. There were some actual, so there was There were unintentional. Okay, so before I say, when I said that there were absolutely no other vulnerabilities that they couldn't have found. Sorry. Yeah, these were like actual false positives where the tool legitimately said, hey, there's a SQL injection or a cross-site scripting here when there was clearly not. Right? So this is probably the fault of the analysis module of those tools thought that they were finding vulnerability when really they weren't. Yeah, super weird stuff. I don't know. These tools are weird. So one of the things we try to do is, okay, how can we compare these tools and say, well, maybe one is better than the other? So one thing we kind of came up with, because we're, I guess, academics and like to make graphs about things, right, is saying like, okay, we can say that, so here we're doing what's called this dominant graph. So the idea was, like, Acunetix was strictly better than AppScan. So Acunetix found 6 vulnerabilities, and that covered the 5 vulnerabilities that AppScan found, right? And so this means it was kind of strictly better. It found all the vulnerabilities plus 1 more. And so that's how we order this one. So you have a really interesting case of NStalker, which found 1 vulnerability that nobody else found, and the same with Burp found another one that nobody else found. So that's why they're kind of off on their side. But I think it missed a really simple one that nobody else found. So yeah.
Did any of the scanners find vulnerabilities that you didn't intend to program in?
Yes, one. A very tricky one, yes. It was kind of like an error page or something. There was like the server name, so you could change the query, or I forget exactly how it was done, but I saw that and I was like, ooh, that's good. So then you have to it's really terrible. You have to start over and run all your experiments, right, to see if any of the tools found that one. Luckily, that was the only one as far as I know, that's it. They're not there for a long time, so I think hopefully all the bugs are shaken out. Yeah, it is kind of a good point of how it's hard to create these things. So how these tools actually work, right? So a lot of them, if you think about a form, right, you're trying to fuzz a form, or you're trying to fuzz query parameters on an application, right? You may have a parameter foo and a parameter bar, and they all have some maybe default values. Well, you want to fuzz and try to test one of the variables. What do you do with the other one, right? Because maybe you change that and you change the application, and now it's no longer doing what you think it should do. So they had to use default values. They had cool cross-site scripting attacks. Some of them were better than others. Some of them had really cool command line injection payloads that would use like backticks and do a ping, and then they would test for timing differences between sending that payload and sending a normal payload. That was a really cool thing. SQL injection, so this was also a technique that Burp used, was a similar timing thing, is they would inject basically, I can't remember if it was a sleep function or something like that, which would cause, so then they could find blind SQL injections by using this technique to do timing detection differences between their requests. So that was really interesting. Remote code execution, so some of them had really cool ways to actually, I think they even had services where they would be like listening on a local port to see if they were able to connect back to try to test these kinds of things. So from doing all that work, right, so we kind of looked at it and we said, okay, what was the biggest problem, right? What was the key core problem of these tools? And it turned out to be something that, as a human, is kind of silly. It's the login form, right? Because the tools would be testing the application, even when we gave them valid username and passwords, right? They test the application and then accidentally log out. And they didn't know that they were logged out. They didn't know that they should be able to log back in, right? And this really becomes from what I like to call the shotgun approach to these tools, right? Is rather than like interacting with it like you as a human, right? You make a request, you get a response, you click on things, you browse the website. They, instead of making one request, they fire off tens or hundreds of requests per second to try to increase the efficiency of their tests, right? And they get back a bunch of responses, and they pass that to the analysis module to try to understand what's going on. The key problem here is what happens when one of these requests logs the tool out of the web application, right? And then all those other requests are now not testing the application in that same state, right? And so really, this is one of the big problems is that, so I was actually just thinking about OAuth. I like the fact that it says web applications in there, right? Because a lot of people say websites. Like websites are just informational things that don't ever change, right? A web application is actually a complex software application that has state that you're interacting with over time, right? And this is a key problem is these tools treat a web application as if it's this static site that they can just fuzz willy-nilly, right, without any repercussions, when really that's not the best approach. So to kind of illustrate this, right, what do we mean by state? So let's say we have super simple web application, 3 pages. At first, the view page is not accessible. I first have to access the home page, then I can access the login page. Then the view page is now accessible. Now I can access the view page and the logout page. And when I access the logout page, the view page is no longer available. And so if we think about this, once again, in a graph terms, right, we have these 2 states. We're either a guest or we're a user of the application. When we're a guest, we can make as many requests as we want to the home page, and we're not going to change the state. Once we log in, though, now we can make as many requests to the home page as we want, and we can make a request to a view page, and now we can log out and go back to the guest account, right? So, this is an incredibly simple idea of state, but the same thing applies when you use any application, right? You're using it, you're interacting with it, you are changing the state of that application. You're now logged into Amazon, you can do more, you can see more things. You can post a comment which permanently changes the state of the application, right? And so our goal here was, can we build a tool, can we build a black box scanner that actually can infer this state graph from the outside with absolutely no knowledge of the website? And so there's an idea called a Mealy Machine, which is basically this graph augmented with outputs. So it says when I'm in guest state and I make a request to the home page, I get response A. And when I log in, I get response B. Now when I'm in this new state, if I make a request to the home page, I get response C. So what we're doing is we're inferring the state of the web application by interacting. So we make a request to home, we get A. We make a request to login, we get B. We make a request to home, we get C. We make a request to view, and we get D. And what we realize is we can, from completely the outside, infer that the state of this application has changed because we make a request to the home page and we get a different response back. A and C are different, right? If we think about the application as a Mealy machine, we'd say, okay, when we're in a specific state, when we make a specific request, we get that exact same output. So when I visit the home page, I'm going to get some response A. And if I make that same identical request later and I get back something different, the state must have changed, right? I must be in a new state now. Now there could have been multiple states in between that I missed. There's a whole bunch of ways that this can go wrong. But this is kind of this key building block that we use to build this thing to be able to make all these graphs. So we have to first say, okay, how do we tell if A and C are different, right? Because we're getting back an HTML response. And maybe if it's slightly trivial changes, we don't really care about that, but if it's something really big, then we do care about that. We want to determine, so we know, okay, I made a request to the home page, and I made a request to the home page, but which request in the 10 requests or whatever that I made actually changed the state of the application, right? How do I determine and try to infer and figure out which one did that? So we have to have a way to do that. And then this state changing idea just gives us an idea of, oh, I'm in a new state. Oh, I'm in a new state. Oh, I'm in a new state, right? But I may be logging in and logging out, which flips between 2 states, right? So we have to have a way to kind of collapse this chain into a graph to try to understand what that actual graph looks like. So I see we're running super short on time, so I'm going to we'll skip through this to a little bit on the evaluation. So we used 4 scanners, wget, skipfish, w3af, and the state-aware crawler. The important thing is the state-aware crawler used w3af's fuzzing engine. We just crawled it in our state-aware way, and we fuzzed it in every possible state. it's actually kind of cool because we can tell what state we're in, and if we get into the wrong state, we can see through the graph how to transition ourselves to the state that we want. And so we evaluated this on a lot of different applications, one of which was WackoPicko version 2. We called it version 2 because we had to remove, there was a one time-based feature. So this is part of the problem with this, and this is why I get to do cool things in academia, like have a crazy idea and then say, okay, let's take all like time-based stuff out and all that stuff out. Let's just see if we can infer the state without any of that, any of those things. So pretty good set of applications. And what we did is we used wget, just a recursive wget as the baseline. And we measured the code coverage of these applications. So how much of that application's code were we able to execute? Because what we learned earlier is a tool that isn't able to execute code can never infer a vulnerability in that code. Right? It kind of intuitively makes sense. And so this is why we use as our main metric here code coverage. So how much of the application can we execute? So we have our applications, and in I think all the cases we were better than the other three. But important is the difference between the blue, which is us, and the red. So that's really the difference between this, what being state aware gets you, is being able to exercise more of the application's functionality and being able to test it in all these different states. What are some interesting things? Skipfish had low of recursive wget. Why? I have no idea. Also here on this vanilla form thing, super weird. This is one of the problems with doing these. Weird things happen, and you're like, oh. I don't know. And these are some of the graphs that it produces, which is really cool. So this is for WackoPicko, the state graph that it inferred. And so some of these things kind of make sense. You have to really look at it for a while, so I won't do that. But you log out, you log in or register. When you're in that state, you can add a comment which moves here, and there's all kind of different crazy ways to move throughout this graph. But all these are kind of state-changing requests. Any questions?
Is there a tool that does this?
Yeah, it's open source, but I'm going to give it's researchware disclaimer. It worked once. People have used it. It is out there though. For those that are brave and willing, or if their advisors make them too. That's kind of how research stuff goes. So you have to use this kind of thing. But yeah, it is out there. There's a whole bunch of limitations, like fuzzing this kind of graph, right? As it gets bigger, gets harder. We don't really have a good way of dealing with something like a comment, right? If you add a comment, it changes the state of the application, but every comment you add, it's kind of like that add comment is just a functionality that's adding to a list, right? It's not really transitioning you to this completely new state that you can never recover from. On the other hand, it kind of is, so that's kind of tricky. So anyway, so I'll go over really quickly. So that's kind of some of the work I have done. Those are papers published. You can check them out on my website. I also have a link to my GitHub profile in there, where both those, the WackoPicko and, oh, actually, I did that slide. So WackoPicko is open source, and it's also part of the OWASP Broken Web Applications project. So it's one of those apps in there. So if you want to check that out, there's a great VM from OWASP that you can download and run, and you can access WackoPicko and check it out and play with the vulnerabilities there. So I want to talk a little bit about the future, right? Like, what are the challenges with these tools? So one problem is that, well, right, now applications are starting to say, well, let's get rid of this backend, right, this server. Let's get rid of the database, move the database to the browser, and get rid of the, okay, there we go. And so now when I make a request, right, I get shipped back an HTML page, CSS, and JavaScript, where this JavaScript is really the key of everything, and it's what we call a client-side web application, right? So it's running 100% on your browser. It's using the local storage APIs to store data in your browser, right? And maybe it makes some requests, but I think it's really interesting to think about these tools because they still have problems with cross-site scripting, right? They have third order DOM-based cross-site scripting here, which you still want to be able to test for and try to understand. So the question is, with these new client-side web applications, right, how do these tools work on them, or do they work, or should they work, or and so we kind of took Backbone, Angular JS, and Ember. So what we did was we created a little note-taking application in each of these three different frameworks, Backbone, Angular, and Ember, and wanted to ask the question, okay, how do these tools do? Right? Are they able to crawl these applications, right? They're still applications. They're now just running on the client using JavaScript. And actually I found that surprisingly, I think one study I saw said from the top like 1,000 domains, 3% of them were using one of these client-side technologies, which was actually really interesting and kind of shows that they're definitely kind of coming up, right? But definitely on the rise. And so we have here the Notetaker app. This is our cool, fancy Notetaker app. Okay, yeah, cool. So, okay, first thing that should jump out at you is this big cross-site scripting bar. Most of you code these into your apps. Cross-site scripting. This was actually our way to detect, because part of the problem is, okay, you have this scanner, right? When you tell it to crawl a web application, you can sniff and store, right? You TCP dump all that traffic that it's making and the responses that it's getting. So you can analyze it later to see, okay, what did it do? What requests did it make? What types of things is it fuzzing? Here, this is all running in its internal browser. So how do we ever know where it goes to the application or where it tries to talk with it? Right? So this is where we're like, oh, they're meant to find vulnerabilities. This is the world's stupidest cross-site scripting forum, right? So you type this in, it's a clear cross-site scripting vulnerability on a completely different page. And this way we can tell, because it will tell us, hey, I saw this cross-site scripting index page, I think is what this is called, .php, which shows us that actually it got to the index page. And if it gets to the search new node page, it will tell us that this is a different endpoint, so we'll report a different vulnerability here. It's kind of a way, it's really difficult to track these things because they're running all on the client. So one of the cool things about web applications is you can kind of see here up in the URL bar, right? So we have, or maybe you can't because it's very tiny. So what we have is this index.html page, and then we have the fragment, the hash, or the hashtag, I guess as the kids say. And then we have /note/new, right? So that's what's really crazy about these client-side web applications is they still have kind of the concepts of routing and URLs, right? But the interesting thing is everything after that hash mark is not sent by the browser to the server, right? The server only gets a request, well, this isn't a server, but the server would only get a request for index.html, and then it uses that fragment as the sub-resource of the URL document. But what Ember JS does is it will use that to figure out what functionality did you want to go to. So it's kind of like a web application, right? There are different URLs that kind of mean different things, and each client-side application can do their URLs differently. So then we have a search feature, and so this is still work that's ongoing. We haven't published this. I thought I'd share this because it's kind of fun. Our initial results was we used 14 scanners, and because we haven't published it, I won't tell you which ones. Only 3 were able to crawl the application at all, right? Which is kind of depressing. Or exciting if you're a researcher. It kind of depends on your perspective, right? And no scanner was able to crawl all of the versions and all of the websites. It's super weird. Like some crawlers would be able to crawl the Ember JS thing just fine, but not the Angular JS. Right? So we're still trying to figure out, well, why, right? That's kind of we always want to answer why, like why did this thing happen? Because that's how we can learn from it. But it's really hard when everything exists in that tool and they're all closed source and we can't test them. Some of them are cloud services, so we literally are not even running them on our machine, right? We're just asking them to get crawled. So it's really interesting there. So I kind of want to end with, who else are there pen testers in the room? I know there's a good number of them. Cool. So these are some of my colleagues from Shellfish when we were in DEF CON. I think this is a hotel room we're in. We stole those, or I'm recording it. We borrowed these tables from the hallways. Used as good desks. So we were in this big suite in the Rio doing the hacking. But anyways, so my goal is to kind of put you all out of a job, pen testers. If I could make an automated black box web vulnerability tool that could do what you do, I would be super happy. Because that's the dream, right? I want to shrink, and the more I think about these tools, right, the more I think they're really kind of like little AI things, right? It's like we're trying to take all of your domain knowledge, right, of how do I break into a web application, squeeze it down into this automated tool, right, a program that anybody can fire at any website and try to find bugs. And I think that's really the strength of these tools. And I kind of kid, I'm probably not going to put you out of jobs. But hey, I got a long time, so. But where this is really important, right? You're here at an OWASP meeting, right? You're already ahead of 90% of developers out there when it comes to awareness of security, right? The key problem is these developers don't even know, right? And so if we can give them the tools and say, here, use this, maybe I showed that they aren't good, but they're getting better, right? And with new cool research, we can improve them so that way we can kind of improve the security of the entire web ecosystem, right? By enabling our fellow developers who don't have that security expertise to test their own websites, right? To find vulnerabilities before they're out there. I heard a good talk once where somebody said that these black box tools, they find kind of the low-hanging fruit on the tree of vulnerabilities, right? So what I want to do is kind of raise the bar so we can find those fruit that's a little higher up, right? And keep raising the bar, making the job more difficult for attackers and really making the web safe. So some of the challenges I see are improved crawling capabilities. You can't find a bug in code that you do not execute. That's really fundamental. Improving the attack functionality. So how can we make the attacks more efficient instead of just using this huge list to try to fuzz all these possible things? Can we be smarter about that? Can we improve the tools and make them smarter? Improving analysis. So can we find new techniques, new vulnerabilities, right? A tool kind of has to already know what's an attack and how do I tell if that attack is successful to find these vulnerabilities. Things like logic flaws are incredibly difficult to detect in a black box manner, right? Because this is logic that's in one specific application. So, and finding kind of hidden bugs, right? So there's been some kind of work on this where, maybe your system uses another system, which uses another system, right? And that data is propagating through there, and maybe at some point some other system can be corrupted. I mean, trying to think of how all these things are kind of intertwined. So with that, I'd like to thank you all for listening to me and being so patient, and I'd be happy to answer any questions.
You said there was a tool that somebody asked about. Is there a name for that, or where can we find information about it?
Somebody asked about the state-aware crawler.
Yeah.
It is on my GitHub. It's really the best place for it. You go to my web, that's our group website. You can also go to my website, adamdepay.com. There's links to all my stuff there. Yeah, that's definitely out there. So is the WackoPicko website too. This stuff will be once we get it published. We have to publish first and then release. So yeah, happy. If you have any questions, please reach out. I'm happy to talk to people, work with people. Some of the things I'd love to do is figure out how professionals use these tools and how effective they are in your hands versus like a normal developer, right? Like that's something that's really hard for me to do and to be like, oh, these tools are helping people, right?
How did you, because you mentioned that you did have issues with the scanners logging out and then not knowing that it was logging. How did you, I guess, make that logic so it knows that it's logged out or logged in, and when it would log out to log back in before it continued scanning?
Yeah, so that was with the state-aware crawler. We were able to, if we were able to infer that there was a difference in state of the web application, we could actually test. We could use that home.php request to say, oh, if I know if I get back A, I'm in this state, and if I get back C, I'm in this state. And then with my graph, I have the transitions labeled too, so I can say, oh, I'm in this state, but I really want to test in this state, right? The other challenge is how do you test the login request, right? Every time you fuzz the login request, you have to log out. And so that's basically what our tool would do, is it would be able to make the fuzzing request, check what state it was in. If it wasn't in a state that it thought it should not be, it would transition out. And then I think as a worst case scenario, we also gave it the ability to like re-roll that VM back to the beginning and make all the requests up to that point, so it was in a known good state.
Gotcha.
Yeah.
A simple observation on talking about trying to infer the state as to whether you're logged in or not. You're requesting the home page over and over again, which was the page that you already had access to as an unauthenticated user.
Mm-hmm.
The more like direct and clear way to do that is to request the view page, because then the application won't allow you to view the view page, so you'll probably get, well, it should not, right.
Yeah.
But if you get redirected to the login page or the home
Right.
page or whatever, indicating that you're not an authenticated user or you get an access denied or anything like that, then you're getting a really clear message that you are not in the authenticated state.
Yeah.
Versus requesting the home page, which depending on how home pages work, a lot of them are the same content, whether you're logged in or not. So what you would want to do is request the authenticated page and then confirm if you get the results of the authenticated page versus you get redirected back to the login.
Yeah, that's, so we kind of, I definitely glossed over it, but the basic idea we used was the link structure of the pages. So we looked at the links and the forms on the page. The key idea there is like, the links and the forms describe what you can do with the application, right? So if there's a new link on the form to a new page you've never seen before, then it's likely that the state has changed significantly. So that's kind of what that home page would be like. On the home page logged in, you'd see a link to view. Whereas on the home page logged out, you wouldn't see that link. But yeah, the problem is when you use like home page in terms like that, everything is crazy and varies, and there's tweets that get pulled in, and there's an ad thing that happens, right? So we kind of punted on a lot of that. But yeah, I like that idea, because it's clear that the view page would have completely different responses in those two states.
Right, then you don't have to worry about parsing the HTML of the page and looking for a link. If you get a 302 versus a 200 response, then it's already over. You know that it's a different state.
Yeah.
You asked for some people who actually use these tools in their jobs. I would say one of the #1 frustrations we encounter with almost every one of these tools is once the scan is done, it's done. And you come back next week and scan it again, and there's just no matchup between those two. Maybe you fixed something, and in the process you broke something. You didn't know that. So you would want to be able to diff those two scans. What got worse? Vulnerability tracking. Do we know about this same vulnerability 6 months ago? Does it still exist?
So kind of like built-in regression testing almost,
Yeah,
or something like that. Like,
I've talked to them with some of these tools, and you need to think at a bigger level than a single scan.
right. Interesting. That's cool.
One concern that I had about the list of missed issues that all the scanners had was whether or not those were issues that the scanners like even claim to look for.
Yes.
Because some of the logic stuff or the authorization things, the parameter tampering, that without context, they don't necessarily even claim to look for that, or because they don't know the difference between ID 1 and ID 2. Are those both yours or not? There's no way for them to even know that, so they don't.
Yes.
I don't think they would claim that they were even trying to find those.
I agree. Well, I don't know. I guess does anybody work for any of these companies before I get so? Somebody does? Oh, okay. It definitely wasn't in that study for me. Some of the tools, well, so yeah, that's a very good point. So actually for a lot of those we do, like I think this is all a summary of a 12, 15-page paper or whatever, right? So there's a lot more details in there. But yes, some of them definitely, I agree, are not quite fair, but it kind of is like, that's where we want to go, right? We want to be able to detect. Logic flaws is very difficult, but like parameter tampering or forced browsing, right? That's, if you know about the state of the application, then you can maybe check for forced browsing by saying, well, there was no link in this state of the application, but there's a link here when I'm logged in. So what happens when I make that request in this state and it's the same? But yes, I totally agree. The more interesting thing is kind of like the differences between them, and like in some applications, I didn't get into it, but some scanners found vulnerabilities without any configuration at all, and some that were behind a login, which means that they successfully created a user account without being told a username and password, which is pretty impressive. And some of the tools didn't, and they were only able to find those vulnerabilities when we actually logged in or gave them a username and password, or used their proxy to log in. Those are kind of our three ways to do it. So yeah, it was kind of, I think those are more interesting about the differences between them rather than all of them missed them. And a lot of those are crawling challenges. Like some of them were cross-site scripting in a Flash applet, right? Cross-site scripting with a dynamically created form with JavaScript. So those I think are the interesting things.
What about apps that detect are being scanned and adapt to your scan? So like if you try to log in 3 times and it's detecting maybe you're not inserting tokens with your logins, it's now just going to block you, and every time it just says you failed login.
I guess I should have prefaced this with my ideal way that these tools are used is in your own environment against your own application, right? Completely closed environment that you control, that you can disable that functionality.
It's all educational purposes.
Yes. But it is interesting to think about those kind of things. Yeah, so yeah, maybe can they detect that? Do they rate limit? Is it up to you? A lot of times they just give you a bunch of knobs to tweak that maybe you don't understand what they do or how to do them, and maybe that's one of the knobs that you can tweak. Yeah, it's really interesting. Yeah.
Kind of related to that, and the thing that you didn't talk about in terms of difficulties for scanners crawling stuff is cross-site request forgery defense. So did any of the applications use like anti-CSRF tokens or something like that to invalidate form requests?
That's interesting.
So that you need to have first obtained like a current and valid request token in order to successfully make posts. That can be a problem where maybe even if the tool crawls it successfully the first time because it's just submitting the post on the page, but if it tries to submit it again and doesn't have a valid token, does it identify that, and is that blocking things also?
Yeah, so I think, definitely WackoPicko doesn't have any CSRF tokens.
So then, did you get flaws in any of the scanners complaining about cross-site request forgery on your application?
I don't think so, because this was from 2009, 2010. I don't know if they were all testing for that. The specific versions are in there, but yeah, that's a really good thing to do. Yeah.
Are you aware of machine learning research in this space?
In what sense?
I'm wondering what would happen if you took some really mature thing like Watson or something and coached it with, here's 1,000 different pen testers hitting the same application. Here's what all the scanners do. Go at it.
Not that I'm aware of, but yeah, there are. Because that's actually kind of more where I'm moving. I'm starting to think in the terms of like machine learning or artificial intelligence or some kind of those types of things, right? Is how can we actually make it more like you, right? When you're actually on a website, right? Because that's kind of what the state thing was trying to do, right? Is when you're there, you're trying to reverse engineer in some sense that application as you use it, right? So I'm trying to think about, okay, what are some ways we can maybe automatically reverse engineer the application or those kind of things. Yeah, I would love to do train some crazy, I'd be worried about it turning to Skynet ultimately, right? Exploiting things, yeah.
On that, you probably want to look at the DARPA Cyber Challenge. They're presenting that
The CGC, yeah.
Yeah.
Yeah, so my team, unfortunately I left Shellfish after they had already qualified for that, or after they had started the CGC stuff. Yeah, those are a little bit different because they have the binaries, right?
Yeah, it's not web applications.
Right.
You can apply some of those principles to web applications. That does.
Possibly, but it's so hard without having the code, right? That's the key problem here. Is I think you can definitely apply some of those problems in the client-side apps, like analyzing JavaScript. But yeah,
Well,
it's,
I mean, part of them, they're like, part of the challenge is they have to patch the vulnerabilities they find.
Yes.
They don't have access to the source code, they just have the binary.
that's true. Yeah. Yeah, it was actually, when we did DEF CON walls, they had some CGC binaries in there. Like, this isn't fair. People are building systems to automatically break these. We're here by hand trying to do it. Yeah.
So how general is your scanner? Could it work against applications that have any underlying legacy machine? Or they have to be very simple ones?
I don't know. To be honest, so it's general in the sense that it is abstracted a bit from wherever, because one of the key problems I have with a lot of these types of scanners is they assume that like query parameters are always going to be in like the query part of the URL, right? Where we all know different frameworks do things differently. Some of them put some things in the path, some of them do all kinds of things. So we're more general in that sense. We can handle different types of applications, which like we had a Ruby application, a PHP application, different kinds of apps. Definitely for this version, it just needed to be no outside things could change the state, right? That was kind of the key thing. It needed to be the user change the state, right? It gets really interesting when you have, what if you have multiple users of the system, right? Like how can the tool learn whether it changed it or some other person did it? But I don't have any insight onto like theoretical finite state machine, Mealy Machine expressiveness of this approach. It's very much a series of heuristics that all work kind of together, and at the end you get these cool graphs. And you're like, wow. Cool. Anything else?
Kind of off topic, but manipulating the fan to get data out of it.
Manipulating the what?
Came out this week where they were manipulating the fan speed to make it like Morse code and get data out of the machine.
Crazy. Like exfiltration, like secretly exfiltrating, like creating a covert channel with the fan speed.
Yeah, and then listening to it with your phone. And actually transferring like 900K a second.
It's actually really cool.
I didn't know if anybody researched it more. I didn't look at it too much, but
I
thought
didn't
that was
either,
awesome.
but yeah, there's all kinds of crazy covert channels in every kind of system. But so, anyways, I think that's I'm up. So, thanks.
Yeah, thanks a lot, Ed.
Yeah, we're probably fine without the next slide. Just a closing slide. Thanks for everyone for coming. The next chapter